and give our last presentation on his experience at Purdue with DDN.
Thanks a lot. My name is Preston Smith. I'm the Executive Director for the Rosen Center for Advanced Computing at Purdue University. So I'm going to talk about our Purdue Computes initiative and how we've leveraged DDN to make that successful. So Purdue Computes was a new initiative announced at Purdue in 2023 with three major pillars. First, strengthening computing with our computer science department and electrical engineering, which I'll talk about here in a minute. An investment in research around semiconductors, and the creation of the Institute for Physical AI. On strengthening computing, one of the goals of Purdue Computes is to strengthen our computer science department to be one in the top 10 in the country. Purdue was the very first computer science department in the country, formed in 1962. With this initiative, we're looking to hire 50 new faculty members across the university. Many of these are going to be in computer science. AI is going to be a key piece of the research that they're going to be doing. But we're going to be seeing researchers hired in this cluster hire from domains all across the university, oftentimes with joint hires in computer science. Outside of computer science, organizationally at the university, computer science is in the College of Science, and if any of you are from universities, you know how these things go. If you're in one college and then somebody else at another college, these are a thing. We also have a very highly ranked electrical and computer engineering department at Purdue University, which sits in the College of Engineering. So Purdue Computes is going to bridge ECE and computer science, make it so that their faculty work together on projects, that our undergraduate courses are shared. Why would you have AI training or computer programming, both in ECE and computer science? They'll do joint faculty searches. You don't want to have, you're recruiting that star AI faculty member that everybody's trying to hire. Why should your ECE department and computer science be competing for that same person? So we're really optimistic about what this is going to mean for computing research at Purdue. The second pillar is semiconductors. Purdue has like I said, the ECE department has a very large and very well-regarded ECE department. One of my favorite things about supercomputing is when we're on that show floor, the number of people at a place like SC who are working in the tech industry and semiconductors and something in very low level working with silicon. How many Purdue ECE grads come up to me and talk about their time at Purdue and all the stuff that they learned? So with new initiatives like the CHIPS and Science Act and all this investing in domestic semiconductors, Purdue is positioning ourselves to be a leader in the semiconductor revolution with 4 components in talent development, research and innovation, economic development, and leadership. This pillar is including a $49 million upgrade in our Burke Nanotechnology Center, which has fab facilities on campus for research. We've recently announced just outside of West Lafayette the construction of an SK Hynix memory fab. So we're really excited to see all the great stuff that we're going to be able to do in the semiconductor world. But relevant to what we're talking about here today in all things AI is we're creating this Institute for Physical AI, the third pillar. So this is going to be leveraging Purdue's strengths in engineering, agriculture, and computer science to solve the world's problems. So normally when I give one of these presentations, I have to go and give a little bit, well, what the heck is physical AI, right? But I really appreciate after the break, we had that great video where like they stole my thunder and they talked about physical AI. So our definition of physical AI is exactly what we saw there. It's not doing AI for fundamental research in AI. Physical AI researchers are not going to be building the next large language models. They're going to be using AI to solve pressing societal problems, all those physical world things that Purdue researchers are known for today. So IPI, how we refer to the Institute for Physical AI, is going to be involving a lot of different fields, many of which Purdue is already very active in: manufacturing, hypersonics, smart agriculture, materials, quantum and drug design. And it has four pillars. Everything has a pillar, right? The first one is we make. So this is things like robotics and smart manufacturing. We had students recently that were starting a robotics club at Purdue, and just in the spring. And since then, there's over 700 students learning robotics, and they're going to be using AI to make this possible. We move. Autonomous vehicles are going to be everywhere someday. You know, I think somebody's driving that Cybertruck that you guys have right now, but it can probably take you across the way. And Purdue has just announced the creation of the ADA Center, which is for autonomous aerial vehicles. If we grow, this is leveraging Purdue's strength in agriculture, which will help us feed the world. And then we thrive, health, you know, think computational drug discovery, and using AI to help with public health. So the IPI mission, we're going to build a world-class workforce, you know, help serve society's most critical challenges through research, education, and outreach, you know, with all of the goals that we see here. But of course, you know, we're here at a technology conference. You know, we want to understand how technology is gonna make this possible. So if we're going to have a physical AI initiative and we're going to hire all of these AI faculty members to come to get them to come to Purdue and do research, we can't do this without world-class computing resources. So to enable this, the Purdue Computes Initiative supported the creation of Gauchi, which is the name of our 2024 community cluster supercomputer. For over 20 years, we've been building these community cluster systems as a joint partnership between the university, where we centrally fund a lot of the core resources, and then faculty bring in their grant dollars or the department's fund out of startup packages to build a world-class resource that are greater than anybody can do themselves. And everybody has some skin in the game. So having a resource like this at a university is a critical tool. If you're trying to hire 50 faculty members to come to your university, if you do not have world-class AI resources, you know darn well that your competitor for those same candidates is going to be doing that. We were very excited here. Dr. Gauchi, Walter Gauchi, was one of our founding faculty members in the 1960s, and he's still around the department at 96 years old, and even published a paper in algorithms last year. So it was great to have him at a dedication event here a couple of weeks ago. So a little bit about the actual system itself. That we built this in partnership with Dell. You know, it's a mixed workload system. So we have a lot of traditional modeling and simulation. So climate modeling, aerospace, fluid dynamics, computational chemistry, high energy physics are all using this. So we have a large CPU-based system, and of course a DDN exascalar-based parallel file system, which I'll talk about here in just a second. But on the AI side, it has an AI partition that's based on the Dell PowerEdge XE9680. This is effectively Dell's recreation of the HGX platform, 8 GPUs per node. And it's about 10 FP64 petaflops per peak, and we submitted that to the top 500, and it looks like it came in around in the 157 range. So that was very exciting. That'll be a great tool for us to recruit those new faculty. But the file system. So we built our file system based on exascalar. We know if we're going to have all these faculty come in with these AI needs, and we've got this powerful supercomputer for all the reasons we've heard throughout the afternoon today. We knew we have to have powerful storage resources to keep all those GPUs fed. So we turned to DDN and exascalar to make that happen. So the file system you see here is based off of 300, 400, and NVX2. 2 heads with 6 EBODs in capacity of disks. It's about 9 petabytes of raw capacity on there, and only in I think about 18 U of rack space. So that's great. I think I look back to our previous AI system, which was built in 2018 using I think the SMA14K, was a rack and a half of just hard drives, and we can get so much more capacity, so much more performance in just such a fraction of the space. One of the things that was great about this is it's all using the QLC flash. We went with DDN because we had a long relationship with using DDN on our HPC systems, but it's also the most cost-effective option that we were able to find, somewhere in the range of 2 to 4x less expensive on a per terabyte basis than other competitors in the QLC-based solutions. But it's performed really well. We've had the system online for just a couple of weeks now. We've got early users on there doing science while our team is working hard at benchmarking on it. Single client performance has been very, very satisfactory, especially when we compare it to all of our other Purdue systems here. Every one of these systems, Gilbreth, our protected data file system, Negishi, these are all DDN-based solutions. I think all of those are 400 NVX. Platforms, but they have a mixture of hard drives and flash. So that all flash exascalar for Gauchi has been a real real game changer, and we're very excited to see how those AI applications take advantage of that. And then my final slide, we were trying hard to get an IO 500 submission in time for supercomputing this week. We didn't get one highly tuned completed, but even for an untuned run, we run the IO 500 benchmark on all of our machines to kind of just establish a baseline with the stock configuration, so we can compare apples to apples. But even just out of the box, the performance of that exascaler on the 400 MVX has been exceeded our expectations. So compared to Negishi, which is our most recent system, about a year and a half old, we were able to get nearly 3x the bandwidth and 5.5 times the IOPS for less than 2x the money. So we're just looking forward to all the great science that we can enable and see what Purdue Computes is able to do, and appreciate the opportunity to share our experiences with you all. So thank you, DDN.
And thank you, Preston. We appreciate the continued partnership. It's great to see the evolution of DDN and Exascaler across, the multiple systems you've had across the past. So thank you,
It's been a great partnership. Thank you.
Yeah.